Welcome everyone on Mamma Mia Dev channel. This is the second video from the Avalonia UI series where we go through what is data binding and how we can use it inside an Avalonia application to make sure the UI and the application data are always synchronized. If you lost the first video, don't worry, I'll put the link in the description. Data binding provides a simple way to get data into your application's UI without having to manually set properties on each control each time a value changes. Therefore, we can say that data binding is a way to establish a mapping between the properties of the object to properties of the UI controls. This mapping can be either bidirectional, where changes in the control apply changes to the underlying object, and vice versa when changes of the object's property result in the UI changes, or single directional, where changes propagate just in one direction. For example, if the user edits the value in a text box, the underlying object's property is automatically updated to include the value entered by the user. Binding is often used with the MVVM pattern, and for the rest of this guide, we'll be assuming that you are using that pattern in your code. The MVVM is an architectural pattern that helps to cleanly separate an application's presentation logic from its user interface, the UI. Briefly, a view is responsible for defining the structure, layout, and appearance of what the user sees on the screen. Ideally, each view is defined in XAML with a limited code behind that does not contain business logic. However, in some cases, the code behind might contain UI logic that implements visual behavior that is difficult to express in XAML, such as animations. The view model implements properties and commands to which the view can data bind to, and notifies the view of any state changes through change notifications events. The properties and commands that the view model provides define the functionality to be offered by the UI, but the view determines how the functionality is to be displayed. Models, instead, are just non-visual classes that encapsulate the application's data. They can refer either to a domain model or to a data access layer entity. Data binding usually finds its place between the view and the view model. But now, let's see how to actually implement data binding in Avalonia. First of all, when Avalonia performs data binding, it has to locate an application object to bind to. This location is represented by a data context. Every control in Avalonia has a property called data context, and this includes built-in controls, user controls, and windows. When using the MVVM pattern, the data context will usually be an instance of a view model. But how do we actually bind UI elements to view models? We can either build everything from scratch using the INotifyPropertyChanged, for instance, or we can leverage a dedicated framework like ReactiveUI or the .NET CommunityToolkit. At the time I'm making this video, most of the Avalonia documentation is based on ReactiveUI. So, just as an educational exercise, in this series we'll try to use the Community Toolkit, making some comparison between the two frameworks when possible. And now let's have some fun with real code. In the last video, we created a very small application starting from the Avalonia template. Just to recap, everything starts in the program.cs, where we instantiate an app instance. The app is a mixture of code and XAML. In the code behind, we can find that we instantiate the main window with a data context. The data context is an instance of the main window view model, and this is going to be the source of all the data binding we will have in place for this window. Let's have a look at the main window. Here on the right, you can find a preview, and the whole window is just a stack panel, which is a layout control that contains a text block and a button. The text block has a name, text block name, and this gives us a variable in the code behind called text block name that allows us to access the text. And the button has the click property set to button on click. This method will be called whenever we click the button. As you can see, this is all done using the code behind. What we want to do today instead is to move all the logic from the code behind to a view model, and so use data binding. So the first thing we need to do is to get rid of ReactiveUI, because as we said before, we're going to use the .NET Community Toolkit. To do that, we need to go to the nugget window, look for the Avalonia ReactiveUI nugget, and remove it. This will cause some errors that we are going to fix. Here we go. The first thing is that we need to remove this extension. We don't need it. Remove the using. Then we need to go inside this view model base. This is a class that was created when we created the project, and it's part of the Avalonia template. For now, we can just remove it. We will go into the details in another video. Once the application is building again without any error, we can move on. As we mentioned during the video introduction, we will start by implementing the data binding logic from scratch using the .NET built-in notifications mechanism. And then we'll proceed by introducing the Community Toolkit, and we'll see how the toolkit will simplify our lives and the code. So we said that our window is using the main window view model as its own view model. Everything we have inside the code behind will be moved inside the view model. And based on the logic of our window, we will need a property to store the value of the text block, and something else that will be called by the button. But first, we need to implement the notifications logic. Let's go to the main view model. We'll see what's the purpose of the view model in another video. For now, let's just implement the interface INotifyPropertyChanged. Let's use the ID to implement everything we need for us. We'll see that by implementing the interface, we've got an event, property changed, that is invoked when this onPropertyChanged method is called. The set field, if I'm not wrong, it's not really needed for now. All right, so anything that registers on this event will be informed in case of a property has changed. How do we use this? To use this, we'll first need a property to store the text value. Let's see how we call it. We call it text block name. We might use the same. So let's create a property string, call it text block name. Once we've got the property, we need a baking field, which is a private variable called text block name. So now when we request the value of this property, we can just return the value of text block name. Text block name can be set to this greeting, I guess. Let's see what was the... It's welcome to Mamma Mia Dev. Yes, the text is welcome to Mamma Mia Dev. So let's go back and let's set this to an initial value. Can get rid of this and Inside the set is where the magic happens. Anytime something tries to set the text block name property, we need to update the baking field to store the latest value. So value is what it's passed to the property. And once the property is updated, we need to invoke we need to call the onPropertyChanged as it is. Thanks to this attribute, the name, this variable will be populated with the property name automatically. I think this can be turned to an expression body. So this way, anytime we set this property, we set the baking field to the new value, and then we will inform all the controls that are subscribed to this event that the property has changed. This way, any UI that is attached to this event will be able to update itself. And there is some magic, let's say, done by Avalonia, and this magic is triggered because when we instantiated the main window, we said use the main window view model as a data context. This way, Avalonia sees this INotifyPropertyChanged implementation and starts listening to the PropertyChanged event. Now that we fixed the property, the label that we have in the main window, we need a way to dynamically change the value, and we can do it by clicking on the button, just like we're doing in the code behind. So whenever we click the button, we want to change the value we clicked, but we don't want to do it with the button on click that is inside the code behind. We want to do it inside the view model, and we can achieve the same result by using commands. Commands have a different syntax compared to the click properties. To attach a button to a command, you need to use the command property, and by using the curly brackets, you can declare a binding. By declaring a binding, you are binding this control, the button in this case, to something inside the window view model, which is main window view model in this case. At the moment, we don't have anything in the view model, so we need to create a method that we can bind the button to. Let's go back to the view model, or actually, let's grab this code from the code behind. Let's paste it in the view model. Let's delete the arguments because we don't need them anymore. And let's set the property we declared before. Let's set it to clicked, for instance. Now let's go back to the main window and bind the command to button on click. We don't need the name anymore for the text block. Now, before we move on, let's make sure the method is public. And let's run the application. Here we go. Now, if we click the button, nothing is happening. And that's probably because, let's see. Oh, yes, of course. The text block is not bound to anything. It just has a text, welcome to Mamma Mia Dev, but then nothing else. In order for the text value to react to something, we need to bind it to something. We can bind the text the same way we did for the button. So here, where we set the text to a hard-coded string, we can just use the binding keyword again and binding to the property we created in the view model, which was text block name. Let's get rid. Okay, the code behind is fine. The property in the view model will react when the value is changed. And this works in two ways. So from the control to the UI and vice versa. So let's give it a try. Okay, if we click on the button, we'll see that clicked. Nice. So what's actually going on? When we click the button is bound to the button on click command. The button on click command will set the property to clicked. When we set the property to clicked, we update the baking field and we fire the onPropertyChanged method. The method will invoke the event, and any control that is listening to this event will be triggered. And it's like we tell the control, look, this property has a new value. Go and check the value. And at this point, a get to this property will be called with the new value, and the UI will be properly updated. So let's have a quick recap. We implemented the INotifyPropertyChanged interface with all the methods. Maybe let's have it on the side like this. Cool. So we implemented the interface, which gave us access to the notification system. We set a binding for the text block to the text block name property. The property has a baking field. Whenever the property changes, we trigger the onPropertyChanged so that the UI is aware of any change. Then we set a binding to the button by using the command property, and the binding to the button on click, which is a method we declared inside the view model. This method will be triggered anytime we click on the button, and it will set the property to a new value. By doing this, the onPropertyChanged will be fired and the UI will be updated. Now, it's not a lot of code, but imagine to have to do this for all the properties that you have in a view model. And by doing this, the view model can easily become a huge class. This is where the Community Toolkit comes to help. By using the MVVM nugget from the Community Toolkit, we can simplify even more this code, and we will see how. So before we move on, we need to install the Community Toolkit MVVM nugget. Let's go to the nugget window and let's look for the Community Toolkit. Here we go. CommunityToolkit.Mvvm. We are at version 8.2.2. Just install it. Nice. Now, to start off, the first thing is, if you remember during the video introduction, we talked about a couple of entities from the MVVM toolkit. One of the entities was the ObservableObject. The ObservableObject is a class that we can use to avoid having to implement the INotifyPropertyChanged every time. So what we need to do is, do you remember the view model base? Okay, now it's a good moment to use it. This view model base is usually a common container for all the common logic that we want to use in all of our view models. So first step, let's extend the ObservableObject inside our view model base. Our main window view model will extend on its own view model base, and we don't need the INotifyPropertyChanged anymore. We can delete all this code. And even if we deleted that code, you can see the onPropertyChanged, it's still there. That's because this is all contained inside the ObservableObject. Cool. Now that we got rid of the INotifyPropertyChanged, you can see that the class of our main window view model looks pretty clear, and we can make it even slicker if we want. Another cool feature that we can use is the observable property. This works like this. We have our property, text block name, and the baking field, right? we can get rid of the property itself and decorate the private field with the observable property attributes. All right, at this point, we can see a couple of errors popping up. The text block name is not declared anymore because it's commented out. And we've got something here, duplicate definition of view model. And we can see that the ID is already suggesting us what we need to do, which is to add a partial class. All right, so any class that it's extending an observable object, the child class, so the last class, needs to be partial. It needs to be partial because we have code that is automatically generated whenever we use any attributes like observable property. Now that we fixed the error by adding the partial class, we can see that text block name seems to be declared. And this is part of the code generated by the observable property. And if we follow the property, all right, so you can see another partial class of your view model, and this is all automatically generated. You can see that they generated the text block name property as it was before, more or less, a little bit better. And you can see that we have a bunch of call, and you can see the method property changed, which is part of the INotifyPropertyChanged implementation. And we already saved some space. Let's test our application to make sure that everything is still working. Nice. And everything is still working. Cool. The last thing we need to see is the RelayCommand, which is another very cool attribute that we can use. The RelayCommand is an attribute that we can use on methods, and all we need to do is to put the attribute on top of any method, like this, RelayCommand. And by putting this attribute on top of a method, a command will be created, will be generated. And we can see this by changing the binding to the button. And instead of pointing to button on click, we will now find also a button on click command. And if we follow the command, we can see that it's inside another partial class. And here is a command generated a method generated that returns an RelayCommand, which is made of, it's an instance of the MVVM toolkit RelayCommand. At this point, things are not really changing for us because this is a very basic implementation. Commands will be very useful in the future when we will have to implement complex commands and especially asynchronous methods. We can even make the button on click method private, and the application will keep on working as expected. Cool, the application is here, and if we click, the label changes. So, final recap. Today we saw how to implement from scratch the INotifyPropertyChanged. We saw how the CommunityToolkit.Mvvm can simplify our life by using the ObservableObject, the ObservableProperty attribute, and the RelayCommand. Cool, that's all for this video. Just a quick reminder that all the code that you see here will be available on GitHub. I will put all the links in the description. In the next videos, we will see how to make more complex applications using Avalonia and the CommunityToolkit.Mvvm nugget.